Welcome to Joe Newton online class. Once more, Happy New Year to all of you. I wish you a prosperous New Year and God's blessings. Yes, we are still on course at Joe Newton online class, learning physics and mathematics, as well as other tips in education. Now, we have on the board here a task on physics, and that task is under the topic transformer. Of course, a transformer is an electrical device used for voltage regulation. What do I mean? It is used for stepping up or stepping down electrical voltages. That is for altering or varying voltages. Good. To avoid what? Power surge damage in our transmission or power system or electrical circuit system. Now, having done this, the task here we have a schematic diagram of transformer. In that diagram, we can see this is the core. This is, of course, a transformer has two sets of coils, the primary coil and the secondary coil. The primary coil is the supply or the mains, while the secondary coil is the output terminal. So this is the secondary coil, and this is the primary coil in this given transformer. This is the schematic diagram. This is the core. Now, then from the information provided, we have that here the primary voltage labeled EP is 120 volts. Of course, you can use the letter V as well. Then the primary current supply is 1.5 ampere. Then go to the secondary arm. The secondary voltage labeled ES, that EMF here, is 60 volts, while the secondary current produced is 2 ampere. So we are now asked by the question, one, to determine the efficiency of the transformer. Then number two, we are asked what type of transformer is this. Of course, we have a step up and step down transformers. So when we look at the information given and the analysis, we'll be able to deduce whether it is a step up transformer and a step down transformer, stating why it is so. First of all, let us calculate the power in the transformer and the efficiency. Before you get the efficiency of the transformer, you should be able to know the power in the transformer. Good. Of course, efficiency of any device has to do with its effectiveness, its productivity, the extent to which it does the expected work. Good. Now, solution. When I have this, first of all, let us find the power input. Now, the power input labeled P subscript P. Of course, power, electrical power is determined by total the voltage and the current in terms of voltage and current, that EMF and current. It can also be determined in terms of resistance and the current. But in our case here, we are treating voltages and what? Current. So PP is equal to IP times EP or VP as the case may be, which is equal to our PP, that our IP, the current in the primary coil, is 1.5 given, times the voltage in the primary coil, 120 volts, giving us this 1.5 times 120 is like saying 3/2 times 120, of course, because 1.5 is the same thing as 3/2. So mathematically, when you divide this, you get 60. 60 times 3, you get 180. So 180 watts. The unit of power is watt. Then let's look at the power output. The power output labeled PS, that's the power in the secondary coil. The S represents secondary coil, P here represents primary coil, which is equal to IS times ES, giving us IS is 2 ampere times ES 60 volts. 2 times 60 is 120 watts. So this is what we have. Now, having obtained the powers, the power input and power output in the transformer system, we can now get the efficiency at ease with this formula. The efficiency of the transformer is given by the efficiency is equal to the power output, be mindful of this, over the power input times 100%. Efficiency is rated in percentage. So the essence of productivity of that device expressed in percentage, that's the efficiency. So the efficiency is power output over power input. That is power in the secondary coil over power in the primary coil times 100%. Of course, efficiency of any device, even mechanically, is the output work or output effect over what the input effect times what 100%. Now, this is equal to the power output, the power in the secondary, that is power output in the secondary, which we obtain as what 120. We substitute. The power input is the power in the primary, which we obtain as 180 times 100 over 1. So how 0 cancel 0 here? 12 divided itself is 1, of course. Okay, sorry, 6 divided 12 here, we have 2. 6 divides 18, we have 3. Because 12 cannot divide 18. So the common factor we can use here is 6. 6 divided 12, 2. 6 divided 18, 3. Remember, whenever you're doing such division, you must use a common factor that can divide both the numerator and denominator. So mathematically here we have, of course, this 3 divided itself 1. 3 divides 100 will give us 33.3. Yes, 3 divides 100 is 33.3. Because 3 times 33 is 99. Then 3 times 0.3 is 0.9. So 33.33 approximately. 33.33. Continue like that when you divide it. So now we are left with 2 times 33.33. So 2 times 33.33 will give us 66.66. We have 33.33 times 2, giving us what? 66.66. So our efficiency here is equal to 66.66%, which can be approximated to be 66.7%. That is to 3 significant word figures. So with this, I believe you can tackle simple calculations involving transformer. Now let's look at the last question we are asked. We are asked what type of transformer is this? Of course, looking at the transformer itself here, the available information here, we know that this transformer is a step down transformer. What is this a step down transformer? So we can say that this is a step down transformer. A step down transformer. The next question now is why? Because the EP is greater than the ES. The EP is greater than the ES. And also the IP is less than the IS. So that is the condition. So for a step down transformer, the secondary voltage, the primary voltage is greater than the secondary voltage. And also the primary current should be less than the secondary current, because the voltage and current are inverse in the transformer system. That is it. Of course, if you are asked the turns ratio here, it will be what? NS over NP. That is secondary voltage over primary voltage. You reduce to lowest and you get the turns ratio. So with this you'll be able to know, with that condition, the voltage, you should know whether it is step up or step down transformer. But for a step up transformer, the opposite is the case. For a step up transformer, the secondary voltage, the number of coils, which is proportional to the voltage, the secondary voltage will be greater than the primary voltage, while the secondary current in that case will be less than the primary current. Of course, the turns of wire there in the secondary should be greater than turns of wire coil in the primary for a step up. But this one is a step down, so that the turns of coils here is greater than the turns of coil for primary. That is the schematic illustration of a step up or step down transformer. Thank you for paying attention to this class, enjoying the class with me. For more of these solutions on knowledge in physics and mathematics, you visit my YouTube channel at Joe Newton Online Class. There you subscribe so that you get notifications each time I upload videos, tutorial videos. You can also follow me on my Facebook page at Joe Newton Online Class.